The ocean looks calm from a beach, but that blue surface is hiding the largest, least explored living system on the earth. As a science analyst who has spent years studying deep sea data, I can tell you the ocean is the least explored place on the earth by massive margin. We have mapped Mars in sharper detail than most of the seafloor, which is wild because the ocean is right here. We know more about the surface of the Mars than we do about the bottom of our own oceans. The secret hidden in the deep are almost unbelievable. So what exactly is down there in the 95% we haven't properly seen? Let's dive into the actual secrets. And the first secret is simple. The ocean is not a place. It is a layered machine. At the top, sunlight powers a bright world of waves, plankton, fish, reefs, and constant chemical exchange with the air. But even here, the ocean is doing something most people miss. It is breathing for the planet. Tiny phytoplankton produce roughly half the oxygen you breathe, meaning every second breath has an ocean signature inside it. These organisms are so small they disappear in your hand. Yet together they steer climate, food web, and atmospheric chemistry. The ocean's surface is also hit back, absorbing solar energy and moving it around the globe like a planetary bloodstream. And that is why ocean currents are not just water moving, they are climate instructions written in motion. Take the Gulf Stream, a warm river inside the Atlantic that helps keep parts of Europe milder than they should be. Beneath that, colder and saltier water sinks, helping drive a global conveyor belt that can take centuries to complete one loop. This conveyor is slow, but it matters enormously because it redistributes heat, oxygen, nutrients, and carbon across the entire planet. Zoom in, and currents become gyres. Giant rotating basins shaped by wind, Earth's spin, and the edges of continents. These gyres can gather floating debris, which is why plastic accumulates in remote zones far from any city. But gyres also trap organisms, nutrients, and heat, creating invisible neighborhoods across what looks like empty blue water. Then there are eddies, spinning pockets of the water that break from currents and carry entire biological communities across the sea. Think of eddies as ocean weather systems, except they happen inside the water and can last for months. Some of the most powerful ocean movements are hidden completely, including internal waves taller than the skyscrapers. These waves do not break on beaches. They roll between layers of different density, mixing nutrients in the dark. On the surface, waves can also become monsters, with rogue waves appearing suddenly in open water like moving walls. Once dismissed as sailor myths, rogue waves are not measured, modeled, and feared by engineers designing ships and offshore platforms. Storms had another secret. They steer the sea vertically, dragging cold water upward and pushing oxygen downward. That mixing can feed plankton blooms, cool the surface, and even change how strong the next storm becomes. In coastal regions, upwelling is even more dramatic, pulling nutrient-rich deep water towards sunlight like fertilizer from the abyss. That is why some of the richest fisheries sit beside deserts where the land looks empty but water is exploding. Yet nutrients can become too much of good things when pollution feeds algal blooms that strip oxygen from the water. These dead zones are not dead forever, but they reveal how tightly ocean chemistry is connected to human choices on land. Now drop below the sunlight zone and the ocean changes from blue world into twilight universe. Here, between about 200 and 1000 meters, light is too weak for photosynthesis, but still strong enough to haunt. This zone hosts the greatest animal migration on Earth, and it happens every single night. Trillions of creatures rise toward the surface to feed under darkness, then sink before sunrise to avoid predators. This daily commute moves carbon downward, quietly helping lock away greenhouse gases in the deep ocean. Scientists call it part of the biological carbon pump, but really, it is an invisible climate service performed by tiny animals. In the twilight zone, lanternfish may be among the most abundant vertebrates on Earth. Yet most people never see one. Their bodies carry rows of lights called photophores, used for camouflage. communication, and possibly confusing anything trying to eat them. This brings us to one of the ocean's most famous secrets: bioluminescence, living light created by chemistry. Some animals flash to attract mates, some to startle predators, and some is lure prey straight into their mouths. The deep sea is not pitch black everywhere, but it is full of messages written in sparks. Counter illumination is even stranger. Animals shine downward to match faint light from above, erasing their own silhouettes. To survive here, invisibility is not passive. It is an active technology evolved over millions of years. Some creatures become glass clear, others become mirror-sided, others turn ultra-black, absorbing almost every photon that touches them. Ultra-black deep-sea fish are so dark that even a predator's bioluminescent searchlight barely reveals them. The anglerfish solves darkness differently, carrying a glowing lure like a fishing rod's attachment to its face. In some anglerfish species, the tiny male fuses to the female, becoming a part of her body for reproduction. It sounds like science fiction, but in the deep sea, survival often rewards solutions that looks impossible at the surface. The vampire squid, for example, is not a blood hunter. It eats drifting organic debris called marine snow. Marine snow is a constant snowfall of dead plankton, mucus, and tiny leftovers from surface life. It may look delicate, but this snow feeds entire ecosystems and carries carbon into the deep. Every sinking particle is a message from the surface, telling deep animals what happened in sunlight days or weeks earlier. This is why deep ocean is not isolated. It is downstream from everything about it. Now keep descending, past the twilight, past the midnight zone, into pressure that would crush most machines. At 1000 meters, pressure is about 100 times what you feel at sea level. At full ocean depth, every square centimeter feels more than a ton of force pressing inward. Deep sea animals survive because their bodies are mostly water, with flexible structures and chemistry tuned for extreme pressure. Their proteins are shaped to work under pressure that would bend ordinary biology out of function. The cold changes everything too, slowing metabolism, so some deep animals grow slowly and live for astonishing lengths of time. Greenland sharks may live for centuries, moving through Arctic darkness with a pace that feels almost geological. The ocean time stretches differently. Some lives happen in a day, others may span empires. And then there are the trenches, the deepest scars on Earth, where tectonic plates dive back into the planet. The Mariana Trench reaches nearly 11 kilometers down, deep enough to swallow Mount Everest with water above its summit. For a long time, scientists assumed this place was nearly lifeless. Then cameras and landers found animals waiting there. Dull amphipods, snailfish, worms, and microbes prove that life keeps negotiating with conditions we thought were final limits. Even here, plastic fragments and chemical pollutants have been detected, showing that human fingerprints reach the planet's deepest rooms. That is one of the ocean's uncomfortable secrets. There is no true away in a connected water world. But the deep is not only a sink, it is also birthplace, especially along the mid-ocean ridge. This ridge system wraps around the globe for more than 60,000 kilometers, making it Earth's longest mountain range. At these spreading centers, new crust forms as magma rises, cools, and builds fresh seafloor. In some places, superheated water erupts from the crust through hydrothermal vents called black smokers. These vents can blast water hotter than 400 degrees Celsius, yet pressure keeps it from boiling normally. When that fluid hits cold seawater, dissolved minerals solidify instantly, building chimneys like underwater factory stacks. The shock was not the geology. The shock was that these vents were crowded with life. Giant tube worms, ghostly crabs, shrimps, clams, and bacteria thrive without sunlight, which is rewriting the rules of ecosystem. Their secret is chemosynthesis. Microbes use chemical energy from the planet itself to make food. That means entire food webs can run on Earth chemistry instead of sunlight, which gives clue for life beyond our planet. If life can flourish in darkness here, scientists wonder whether similar ecosystems might exist under ice on Europa. In this way, the deep ocean becomes an astrobiology laboratory hiding on our own planet. Not all chemical oases are hot. Cold ships leak methane, sulfide, and other compounds from the seafloor. Around ships, bacteria again form the foundation, feeding clams, mussels, worms, and strange communities in the dark. Methane can also freeze into gas hydrates, ice-like crystals that burn if you light them. These hydrates store enormous amount of carbon, but their stability depends on pressure, temperature, and changing ocean conditions. Another deep secret looks almost supernatural. Brine pools, underwater lakes so salty they sit on the seafloor. The boundary between seawater and brine can look like shoreline, complete with waves, ripples, and toxic edges. Animals that fall into some brine pools can stun or kill because the chemistry is too extreme. And yet, microbes live even there, proving again that life specializes in places that seem impossible. The abyssal plain is different. Wide, cold, flat, and so vast it is the largest habitat on Earth. It may look empty, but every square meter contains microbes, scavengers, and traces of ancient surface blooms. Sea cucumbers vacuum the seafloor like slow biological recyclers, processing sediments for the smallest bits of food. Brittle stars, sponges, anemones, and worms create a quiet city where everything moves at the speed of scarcity. The ocean is also planet's largest carbon sink and regulates our global climate through massive conveyor belt currents. But these secrets are increasingly threatened. The deep sea is one of the last truly pristine environments, and we are already disturbing it. Every new expedition discovers dozens of species unknown to science. The ocean still holds countless secrets we haven't even begun to understand.